It's time to get started. It's, I guess, Nana Chikim by Sean. Just kidding. Flux utilize unidirectional data flow to sync list and scale faster by Sean. Thank you.
Okay. よろしくお願いします。Okay, so let's get started. Hi everyone. My name is Shohei Kawano. I work at a company called Tote, which is a subsidiary of a company called CyberAgent. And I'm doing Android development. And today I'm going to be talking about Flux, which is an architecture introduced by Facebook. But today I'm going to talk about it specifically for Android application development. So before I begin, I'd like to ask you guys some questions. How many of you have used Flux before, either for web applications or Android applications? Okay. Quite a few. Okay. For Android specific? Same amount. Okay, that's great. I hope you all can learn something new from this session, and if that happens, I'm very happy, and I try my best. So to get started from the basic, what is Flux? Flux is an architecture introduced by Facebook at F8 conference in 2014. It's made originally for building client-side web applications, but nowadays it's kind of getting popular in Android as well. And the key feature for Flux is that the data flows in one direction. And the official documentation on GitHub also mentions that the most important concept is that the data flows in one direction. This is the simplest diagram that Facebook gives you to show a flow of data in Flux architecture. And in this session, I modified it a little bit to make it easy to understand. So eventually, the flow of data in this session looks like this. Having looked at this diagram, how do you feel about the notion of unidirectional data flow and the diagram itself compared to other architecture? To me, it's kind of simple at first. I personally think that the data flow is kind of intuitive. The notion of unidirectional data flow is kind of simple. And I think this is a good thing because if your team uses Flux architecture and if a new team member joins to a team and who doesn't know anything about Flux architecture, this is still simple enough for them to motivate start learning from scratch because it looks simple. And it is actually simple once you learn it. So let's look each component one by one. I'm going to explain briefly and quickly what the component is and the role of each component is. So starting from view is, as you can guess, it describes user interface. It renders UI based on stored state change. So that means view can also be considered as store subscriber. And the view itself, therefore, doesn't have any state. Next, action creator. It's kind of a helper class. What it does is it creates action and passes that action to dispatcher. And there's no state that belongs to action creator as well. And next, action. Action is something that's like container. It's created by action creator and dispatched by dispatcher. And it's dispatched to store. It's there to deliver new data or state to store. And it can be described as, it also describes the internal API of the application. And dispatcher, it's the center of all the data flow in Flux architecture. Dispatcher dispatches action to store. So dispatcher is kind of like a bridge between the view side of the application and the store side, the data side of the application. So if dispatcher doesn't dispatch anything, there's no data flow in the application. And of course, dispatcher doesn't have any state as well. And finally, the store. Store is the state manager, and it changes its state and data that it contains only by receiving actions. And therefore, store has states and store has internal logic. And to make it clear, the store is the only state manager in Flux architecture. But why do we have like this kind of unidirectional data flow diagram, and why we have like 5 separate components? Why we need to make store the only state manager? Well, of course, you can easily guess that by having only one state manager, you can easily like manage the state compared to like having 2 screens, having different state for each screens. But also, one of the biggest benefits that I think that Flux has is that it implicitly makes you follow the notion of dry, that don't repeat yourself. We will look into the detail later, but by defining 5 separate components, feature-based components, and the store with the only state manager, you will find that new views or features that you are adding to scale your application need to care or can reuse some of the components that you already defined before. So you can reuse some of the components like store or action creator later when you scale your application. So that's, I personally think that's one of the biggest benefits for applying Flux architecture for Android. So let's see how we can construct Flux data flow by imagining that you need to show a list of users in one activity. By the way, the image I stole from Google material design website. Thank you, Google. And okay, so as we see, I'm gonna introduce some of the libraries I use. Don't worry if you are not familiar with some of the things. It doesn't matter the library itself. It matters like how you implement it. And I will also show alternative libraries for some of these libraries. So you can implement in your own way as long as you can implement Flux components. So in Android, there's a screen that opens up when user launches the app. And that is considered as view in Flux architecture. So in Android, activity, fragment, or Android's platform-specific views like recycler view or custom view. Your own custom view can be a view in Flux architecture. And in our example, we will use activity. So we need to implement activities on create. And this is the activity source code, what it looks like. And let's see the layout file first. We use data binding to define isLoading variable. And we have, of course, recycler view with the ID UserList and the progress bar, which visibility is going to toggle based on the isLoading variable. So to start, let's assume we use Dagger to inject all the necessary fields first. I already injected some of the fields, but don't worry, I'll explain it each later. So we have what's called action creator, and we have store, and we also inject a recycler view adapter into the activity. So in activities on create or any view, like activity or fragment, we have 3 steps to do. We initialize view, we subscribe state, and we create and dispatch action. So first, initialize view. This is something that we always do. Like we set on-click listener, or we initialize layout manager and add it to recycler view, and so on. It's a simple thing. And subscribe state. Let's say we subscribe to loading state. Don't worry, I'm going to explain it later. But we have what's called loading store. And we subscribe to loading state using auto-disposable to automatically dispose the observable on activities on destroy lifecycle. And we add the value to the isLoading variable to toggle the progress bar visibility. So, and in order to have more space in the slide, I will refactor it to extract these things into private function, into init view and subscribe state. So it's going to look like this. And then we're going to create and dispatch action, finally. So we create and dispatch action by calling action creators function. In this case, show user list. And that's it for the view part. So I'll quickly go through. So from next view to action creator, So I already called action creator's function. So this is the part where we move from view to action creator. And from action creator to action, so we're going to create an action inside action creator. So this is the action creator, how it looks like. So what it does is it calls, it fetches a list of users from the network. And if it's on success, we get user list. And if it's on error, we use a throwable error. And that's basically what action creator does. And next, we're going to initialize loading action. So let's see how loading action is initialized and how it looks like. So loading action is initialized here. There's loading and idle. And the loading action itself is declared as sealed class. And it has a public property called activity key. The value of it is the activity's class name. And there are two classes. One is called idle and one is called loading. It's a simple thing. Same for user list action. User list action is initialized here. So we have a show user list class and error class defined. Show user list receives user list model as a parameter, and the error class receives a throwable error. Also a simple thing. And next, we're going to move from action to dispatcher. Once we create action, we pass the action to dispatcher. So inside on action creator, we have dispatcher, and we call dispatch method in those places. And if we look carefully, when show user list function is called, we immediately dispatch a loading action. And then if the API call is successful, we dispatch user list actions, show user list action, and then idle. If it's on error, we dispatch error action, and then idle action. So how dispatcher dispatches these things? In this case, we implement dispatcher using event bus. And there are three public functions called dispatch, register, and unregister. Dispatch is, what it does is it basically passes the value to event bus to broadcast something to somewhere, like throughout the application. And for register, we register observer for it to start observing the dispatch event. And unregister, vice versa, unregister observer from dispatcher to stop observing. And for dispatcher, we can also implement in the same way using RxJava or event bus, or maybe you can implement by your own. As long as you can broadcast action to throughout the application, it can be anything. Next, once dispatcher dispatches action, the store will receive the action, right? So let's see the code inside. So inside action creator, we dispatch action. And so first, let's look at how the store will receive the loading action once loading action gets dispatched. So inside action creator, we dispatch loading and idle action. And once it dispatches it, the store will receive it. So this is the class called loading store. And let's take a look at those code from the top. So inside the constructor, we inject dispatcher and what's called navi. And on init function, basically what it does is on activities on create lifecycle, we register the store to dispatcher. And on destroy, we unregister the store from dispatcher. And for observing lifecycle events, you can, of course, use Android architecture components lifecycle, or in this case, we use Navi, or maybe you can implement by your own, by maybe implementing Android lifecycle, like activity lifecycle callback, or maybe more. And so when the action gets dispatched, the store will receive it. In this case, the green robot event bus has annotation called subscribe annotation. So once we annotate a function with subscribe annotation, we can receive the value. And inside the on function, we have logic. So in this case, first it checks if the action and the store are on the same activity by checking the activity key is the same, so that if two activity is open and if those two activities receive the same loading action, only one activity has to show a progress bar or whatever. So in order to check that, we have activity key in this example. And we have, inside loading store, we have published subject called loading subject. It has Boolean type. And when the action is dispatched, it checks the type. So if the loading action is loading, we pass true to the published subject. And if it's idle, we pass false. And next, let's see what's going to happen when UserList action gets dispatched. So from action creator, we dispatch UserList action. And inside store, it's going to look very similar. But one thing that's different is, in this case, we use data binding observable array list to manage the list of user. And since we use observable array list, we need to register the callback when the list data changes. So we have add on list change callback and remove on list change callback function public. And we're going to use it later. Other than that, it looks the same as loading store. So we initialize and register, unregister based on the activities lifecycle. And inside on function, we have the same thing, except in this case, we receive user list action. And when action is show user list, then we add a list of user data into user list. Okay, and so once the store changes its state, the view needs to subscribe the state change, right? And how we do that? So for loading case, we use RxJava to stream loading state change. So this is loading store. And once we pass a true or false to loading subject, we also have a public property called loading state, which is a hidden version of loading subject. The hide function basically is when we have published subject and we want it to be subscribed as observable type, we use hide function to from the subscriber. It's going to look like observable, but it's actually published subject. So we're going to use loading state for the view, and that's what we written for the first time inside activity. So we subscribe to loading state, and when it streams the value, either true or false, we pass it to is loading, so that progress bar will show based on the value. Here. And yeah, so the data binding will react to it, and then based on the visibility, based on the value, it changes the visibility. So far, so good? Okay. And for the streaming user list change, we use data binding. So when user list action gets dispatched and we add the new user list, we have a recyclable adapter we inject into activity, if you remember. And then inside adapter, we declare a list change callback to declare what to do when the list changes. And inside adapter, just like stores, we add or remove a change callback based on activities lifecycle event. So on create, we add callback, and on destroy, we remove it. And we, just like we do normal, we implement our override on bind view holder and get item count. And for the data, we use all the data from the store. Since we inject a recyclable adapter, we can inject store as well. So inside adapter, we have store, and we use the data from the store. And that's how we construct data flow. It's kind of a lot of code, and you may be overwhelmed. But once we construct the data flow, the next step will be easy. So from the code that we showed before, we can see a list of user. And the power of applying architecture, or especially Flux, gets obvious once you need to scale your application. So for example, when you want to add like favorite, or like you want to show a user detail screen, you know, like when there's a star button and if user clicks it, it's going to toggle. Or like if user clicks item list, it's going to show a detail page. And there's a fab also in the detail page. And if you want to click it, the data will be synced to a list of user. And if you want to create that thing without any architecture, it's going to be horrible. Like maybe you want to use start activity for result and handle the data. And if there's data change, you want to receive it in on activity result. Or maybe on resume, you call API to like refresh every time. It's going to be like pretty difficult. So let's take a look on how we can implement that favorite functionality in the list at first using Flux architecture. So inside the adapter we declared before, we declare and inject another action creator. In this case, user action creator. And then when fab icon is clicked, we want to favorite the user. So we call favorite. Right? And inside user action creator, just like the ones before, we call API. And if it's complete without any error, we dispatch a favorite action in this case with a target user ID. Right? So once we dispatch the favorite action, inside the user list store, which is the one we defined before, we add another function called same on, but different type. In this case, we receive user action type. And when the action is favorite type, we find the target user based on the user ID and update the data based on that. And by adding these functions, you can implement favorite feature for a list, and it's very easy, kind of. So when user clicks the fab, it's going to toggle, I guess. And for the user detail part, first we need to start activity. So inside user list adapter, we declare and inject another action creator. Let's say we call it activity action creator in this case. And when the root view of the list item is clicked, we start user detail activity. And inside activity action creator, we have a bunch of start activity methods. And for start user detail activity function, we just simply create intent and start activity. And that's it to show a user detail activity. And let's implement the fab, a favorite part. Right? So this is a user detail activity. And this is, it looks the same as a user list activity almost. So we inject user action creator, the one we created before, into the activity. And when the fab is clicked, we call favorite function here. And so when user taps button, the favorite function gets called. And if we go back, the data is already synced in this case. And this is surprise, kind of. And why is that? This is because we, inside user store, we already implemented how we should react based on the action. So in this case, when we dispatch favorite action, the store will find the target user, and if there is, the list will automatically get updated. So we already implement the logic, so we can reuse some of these things as we scale your application. So that's what I mean by dry. In order to add new activity or like new feature, you don't necessarily need to implement everything from the scratch. We can reuse some of the logic once we construct the Flux data flow. So everything looks great, and I will introduce some other great things about Flux. The first thing is the code consistency. So just like we saw, inside activity of fragments on creator, on view created, basically there's only 3 steps: initialize view, subscribe state, and create and dispatch action. So that all the activity and fragments have similar private functions like this one. And it looks the same. So you having these code, only these code, you will never be lost in activity or fragment with spaghetti code or whatever. And for action creator, we do this like similar thing. If we need to show a loading, we dispatch a loading action. And if API call fails or success, we dispatch the data or throwable type. And then if there's a loading process, we also push the idle. And it's gonna look the same, kind of. And the next, the logic inside the store becomes kind of the specification of your application by using Kotlin seed class and when keyword, and if you can name the action with descriptive names. By reading the logic inside the store, you can tell how the app should behave. So just like we saw before, for loading action, so it's like when given action is loading, the next loading state is true. If it's idle, then false. It's kind of easy to read, just like in English. Same thing for user action. So like when user gets favorite, then find target user from UserList and update as favorite. It's kind of easy to read. And this is the internal API of your application, right? So I believe the logic inside the store can be the clear specification of your application. So if new team member joins to your team, and when they look there, this kind of source code, it's easy for them to understand how you structure your application as well. There are several things you need to be careful as well if you use Flux architecture. The first thing is dispatcher. In this example, we use event bus, and nobody likes event bus. So event bus, a similar kind of mechanism, is hated because it can be abused, I guess. But remember, that in Flux architecture, the dispatcher only cares to dispatch something to store only. So I think if you use Flux architecture, those things can't be abused. Or if it's abused, you will notice it immediately. So I think it's not a huge problem. But if you implement dispatcher, you need this kind of mechanism at least. So if you don't like pub/sub kind of mechanism, that's something maybe you need to bear. Also, sometimes it's kind of hard to tell in which component you need to put the logic inside. Sometimes you may want to put the logic inside action creator and sometimes store. And remember that the store is the only state manager and it has the internal logic. So if you kind of get lost or don't know in which component to put the logic inside, I recommend that you put the logic inside store. There are two reasons. So the store can be reused with the up-to-date internal logic. So if you have two logics inside both action creator and store, new team members, if new team member joins the team, it's kind of difficult for them to understand in which component they need to put the logic inside. So they will get lost as well. So in order to keep consistency, I would recommend you put the logic inside store rather than action creator or any other place. Okay? And finally, some other tips. In Android, if you can use data binding, use data binding because you can stream all the data change using RxJava, but like the example we saw before for a list of user, if we use data binding, the data sync will be kind of automatically rather than you need to stream the data to activity first and then add the data manually. So it's kind of easy to sync the data if you use data binding. And second, the construct feature-based. What I mean by that is if you need to construct Flux data flow from scratch, consider constructing it feature-based rather than screen-based. So you have two activities, and without thinking, you may want to create a Flux data flow for both activities. But think of it as a feature-based rather than screen-based. If you create a data flow for screen-based, it's kind of decoupled too much. So maybe you want it to be feature-based. And finally, if you get lost or if you don't know anything, just talk to team members or ask team members. Because Flux is not only for Android, but also for web or iOS. And that's it. Thank you so much, and enjoy Japan. Okay.
Thank you, Sean.